Generation sequencing. So today resource person is Dr. Vipin Balan. He is Bioinformatics consultant of Omics Gen Private Limited. So sir, I would like to welcome our resource person on the behalf of Department of Biotechnology and Indian Science Congress Association Cochin Chapter. Welcome you sir, and let me invite Miss Alfie P.S. to introduce resource person.
Good morning to all. Welcome to the 4-day session of Faculty Development Program G to Drugs, a Bioinformatics approach. And it's my immense pleasure to introduce our resource person of today, Dr. Vipin Balan sir. He is currently working as Bioinformatics Consultant, Omics Gen Life Science Private Limited. He has also worked as Senior Bioinformatics Analyst at both Agri Genome Lab Private Limited and Science Genome Lab Private Limited. He has pursued his Doctor of Philosophy from University of Palermo, Italy, and he has also been published 15 papers in high impact factor international journals, and his research interests are next generation sequence data analysis, bioinformatics tool development, genomics and proteomics. And today in the morning section, he will deal about the topic Introduction to Next Generation Sequencing, Basic Linux Command, and on our afternoon section, he will explain Perl Basics Bioinformatics. I wholeheartedly welcome you, sir.
This session is very interactive session. Maybe you have to answer some of the questions because you may be familiar with a little bit bioinformatics. So, anyone having any experience in bioinformatics? I think maybe all of you are from biology background, right? So, you know a little bit of, no, not little bit, you know very good molecular biology, right? Maybe genetics and that aspect of biology, okay? So, actually, I did my BSc from physics. So it is around 2003 or 4. So after that, this bioinformatics started. First in Kerala, maybe in India. So I did a master's in bioinformatics. So it was very difficult for me to understand what is bioinformatics because it was the start of the bioinformatics, and the teachers who are teaching me said they don't know about what to teach. So after completing my master's, I got a immediate job. And there I was working on different kind of genomics program. So later this next generation sequencing came. So from there on it is rapidly increasing, and there is a great need for bioinformaticians all over the world. So luckily I got experience to join Cycle Labs. That is a startup in Kerala. So they have the sequencing facilities, they have the machines. So it is a very good experience for me to start from the scratch so that I can learn how it is starting and how to do the things in the perfect way. So maybe there will be errors because we are the beginning. We don't know like to whom we have to ask. So we have to go and search in Google and we have to find out solutions. Okay. So after that, I learned a lot of things in the bioinformatics, but still I am learning because there are new technologies and it is a rapidly evolving field. So a lot of things are coming new. So I tell you bioinformatics is a very challenging field. Okay, so what is a bioinformatics? So it means you have the data, biological data, and you need to understand it. So biologists maybe 20-30 years back there will be very few data. So after the sequencing of human genome, there is a rapid growth of how to understand the data. So you have the sequence, but number of sequences. So you need to identify the genes. Okay, what are the genes there present? You have to find the proteins. Okay, then you need to understand what is there in the long ATGC sequences. So from there, the bioinformatics evolves very rapidly. So you have to manage with the big data. So in this scenario, the biologists they cannot do it because they don't know much about how to handle this big data. So they need some support from the other people who knows biology as well as to handle this big data. Okay, so for handling big data, you have big flat files and all the sequence data or related to the gene information, protein information, etc. So they should know the computer science. Okay, so basically bioinformatics means biology plus big data analysis. Okay, so bioinformatician means his main role is to understand this biological data and tell the biologist, okay, what it is. Because biologists, they don't know how to understand it. So, in the bioinformatics, the bioinformatics person, he should know about programming languages such as Perl, Python, etc. He may know about the proteomics analysis, the system biology, microbiology, pathway analysis. Not only this, you have to know about the biochemistry, biophysics. So, in general, the bioinformatician, he knows all kind of science, but he knows everything, but he is not master of nothing. Okay, so that is the basic of the bioinformatician. So, I'll tell you like different roles of a bioinformatician. So, first one is the scientific data curation. So, you know, day-to-day lot of publications they are getting published. So next is whole genome sequencing. Whole genome sequencing as well as there is like a exome sequencing also there. So whole genome means it is a resequencing or maybe it is a de novo. Okay, I'll tell you about what is de novo. So we have the human genome, it is already sequenced. So we have a reference. Okay. So if you are studying on a human, no need to sequence it again because you already have the reference genome available. You can download for NCB. So in that case, what you will do? You will do the sequencing, you will go and check with the human genome, or align with the human genome to find out the variation and all. Okay. But you are going and doing some, your organism, it is not sequenced yet. Okay. So, how we can do the analysis? So, that is a big question. So, there comes the de novo analysis. So, de novo analysis, like the sequencing is same. You have the small set of sequences. But the thing is that, how to assemble to make a reference genome. So it is a big question and there are a lot of tools available. So it is a time taking because in that case it will go and check the sequences with the similarity, the overlapping, and it will make the long code mix. Okay, so that is called the assembly, genomic assembly. So at the end of the day you have the long stretch of sequences which is called as a code mix or assembly, and using that assembly as a reference you can do your analysis. But still it is not that much accurate, you know, like due to the sequencing, there will be some errors, or you cannot sequence that much length of the length. So this will affect the de novo analysis. But if you are not knowing anything, but you know something, that is better, right? So in that case, people are using the de novo sequencing. So whole genome sequencing means like this is a resequencing. Okay, so suppose you are doing a resequencing of a person from the Kerala, like you are taking the blood sample and you are taking your sequence the entire genome. Okay, so you need to find out what is different from the reference. So you can do weighting coding, means like where is the mutations and all. So it will report the SNPs and indels. Okay, and you can see some of the SNPs it is already there in the population study, so you can get from the 1000 genome project. Okay, and maybe it is something related to like a race or something like that. So you can identify. So people are doing the whole genome sequencing. So in the case of cancer, what will they do? They will go and sequence only the cancer genomes. Okay, and they will check. Okay, this variation is reported. So in that case, according to that mutation, they can prescribe the medicine. So this is called the personalized medicine. Like nowadays, people are doing it. Next is ChIP-seq. I am just telling in a broad way, I am not going in detail. I am telling the applications of next-generation sequencing. So ChIP-seq is to understand the interaction between DNA and protein. Okay. So here also they will take the interaction of the sample and they will go and check how many reads are there. So if you get a peak, you will tell, okay, this is a particular location it happened. Okay. So here I am just telling you that it is a combines the chromatin immunoprecipitation with the massive parallel DNA sequencing, and if you get this peak, you can tell that is the site. Next is a RIP-seq. RIP-seq is similar to the ChIP-seq, but here you are studying about the RNA binding protein. So that is the RNA protein interaction. The ChIP-seq you will go for the DNA and the protein interaction. Okay. So it is the method is almost similar. Like you have to go on the peak and you have to if the peak is there, that will be the binding site. Next one is methyl seek. So methyl seek is to understand the methylized state of the whole genome. So it is like you can identify the epigenetic difference, the analysis. Okay. So what is epigenetics? Any idea? Yeah, so it won't change the DNA. Okay, due to environment, it will regulate the expression of the particular genome. So here with the methyl seek, it is one example of the epigenetics analysis. So you can find out which cysteine that it will be the methylation is starting where, like which sites it is in the direction occurs. So another application is QTL-seq. So this QTL means quantitative trait loci. So like the population genomes, like suppose you have some rice samples, 100 samples. So you need to understand, some of the like progeny, the plants is high height, what is the high weight. So you need to understand. Using the QTL-seq, you can relate the genotype to phenotype. Okay, so you can get the genes which is responsible to the height, weight, or whatever it is. So you can use the QTL-seq analysis. So DDR is another one. So it is also saying kind of the similar to QTL-seq. So like for the library operation, they will do the double digestion restriction associated with sequencing. Okay, so the objective is same. Next one is the metagenomics. So metagenomics is to understand the, like you have a sample, soil sample. So you need to find out what are the microbes present in the sample. Okay, so in that case you will go for the metagenomics. Okay, or you have the find out the 16S rRNA, the variable regions you can understand. So we can go with the metagenomics. So you can also compare two soil samples and find out what microbe is more in one particular sample, like that. So in general, bioinformatics means it is a combination of different fields, like it is physics, chemistry, biology, computer science, statistics, etc. So it is a integration of all these fields. Okay. So in this section, next section, I'll tell you what is the basics. Like I'll teach you to some of the Linux commands, and next section I'll teach you some of basics of the Perl programming, because it is essential. Because my ultimate aim is to do a RNA-seq analysis of a small set of data to understand what are the genes are expressed or it is down-regulated. Okay, so for doing it, you need to know what is Linux and how to write a smart program. Okay, so any questions related to this? No, whole genome sequencing, like the reference base means it is already there, reference. In that case, okay, of course, we can do this thing because we can suppose human genome. Okay, so like suppose your sample is sequenced, so you have all the chromosomes and you can map with the HG19 or GSS38. That is the latest one. So and you can see the variations there. Okay, so from your gene how much difference from the reference. That is one thing. Second one is like a de novo, like there is no sequence available. So it is very difficult. So what you are doing, I'll tell you, I told you, you sequence everything and you try to assemble the smart stress. Maybe you will get a very long one. So people are doing like a Illumina sequence because it is cheap. And PacBio also, because PacBio is a little bit expensive, but it is not that much accurate. The posted thing in PacBio is like you will get a long read. So the combination of both, you can assemble using the Illumina reads, and the gap you can fill using the PacBio. Okay, so you can make a long reads, but still you cannot get the complete set of the chromosome. So maybe you will get a 1,000 like sequences, long sequences is good, because sometimes we get 5,000, 6,000, depends on, because there are a lot of factors affecting the quality and all. So, but once we complete it, then what we will do, we will go and do the gene prediction. Okay, there are a lot of tools, Augustus, GenScan, etc. So they have their own algorithm. They will create the sequence. They will tell, okay, from there, because you have to train some sets. some similar kind of organism sets, they will read the exon intron structure, and from your input, it will go and predict, okay, this can be a gene, okay, and also it will predict the protein sequence. So once you get it, you have to do a blast, okay, to find out the gene, okay, of the similar one, and also the protein, and from the unique protein you will get annotation, like a genome or gene, etc. So this is the maximum you can do, okay.
Can we identify the gene or even the mRNA in the partial genome sequencing as well?
Yeah, you can do the gene finding tools to find, just predict it. If it is working, you can get the mRNA. But I'm not telling it is 100% accurate. Okay, it is possible. Like you have a sequence, you can give input to Augustus or GenBank, and you have some model organism. It will predict according to the model organism, and it will predict the genes and the mRNA proteins. Any questions? Deep sequence same. Like because we have to sequence maybe 43 times, because there will be sequencing errors. Like if you have only one sequence and you are finding out that there is a variation, it may be due to the sequencing problem. So what people will do, they go with some 30x, means 30 times same thing will be sequenced, or 80x. So in the exon analysis they will go for 80x, because 80 times it is reported as a variation. So it can be a variation. But if it is going 10x, 10 times it will report as a variation, but rest of times it didn't report it. So in that case we cannot say it is a variation. So if you have more depth, that much accurate. Yeah. So that means like you have the confidence level. So if you sequence 10 times, and if you sequence 80 times, which will give you confidence? 80 times. Yeah.
So how do you know the quality of
Yeah, so
based on these statistics?
No, actually there are a lot of checking in between, like for the library preparation, like once they collect the samples, I don't know much about those things, because but I know, like they will do those things. So there is something like ring analysis, RNA integrity number. So it is like they will tell, okay, if it is ring values above 7, the RNA quality is good. Maybe it is more than 4 to 5, it is okay. But less than 4, they will tell, okay, we are not going to sequence it because it is degraded. Okay. Sometimes if you get more than 7 also, we may not get the results, the stats. But it may mostly will be accurate, more than 7, ring value. Yeah. So once you, before doing all this sequencing, the library preparation level, they will check the thing. So once you have the sequence, then also we have some kind of checking. Okay, so that we have to check the FASTQ quality. Like the FASTQ quality check, we know okay how good the read is. So I'll tell you the tomorrow I'm going to take it. So I'll show you like how you can check if you have a FASTQ file, like how the reads, what is the quality. So if it is less quality, we need to remove it before proceeding our analysis. So there are 2-3 kind of error checking. As well as once we have the up and down regular genes, there is something like a p-value. Okay, or Q value, that for a statistic. So upon that only we will go and then select the genes. Okay, so because these things, the accuracy is very less, but the thing is that we cannot sequence everything using Sanger. But using the NGS analysis, they'll get a list of genes, and if our gene of interest is there, okay, we have a very good confidence, okay, this is correct. Okay, then again they will do PCR of those genes. You can see, if you read any RNA-seq papers, you can see in just data analysis, you got these many genes, then again they do the RT-PCR to verify it. There are a lot of, you can similar search, there are a lot of papers available there. So mostly they will, because in the bioinformatics papers, they'll explain the pipelines they are using, because day to day new tools are coming. So there are big comparison like, okay, which tool is better, okay, what is a good thing, what is a... So tomorrow I'm going to take one pipeline. So maybe I'll tell you the alternate tools. Okay, you can also try, because all these tools are freely available. You can download, but the thing is that it will work in the real station. Okay. Any questions? I think maybe you get some basic idea about what is bioinformatics. Okay? Yeah. In this session. So I'm going to give some training on the Linux or Unix commands, then some basic word programming. Then after that, I will give you some introduction to NGS data analysis, and then we are going to do an analysis of RNST, okay, to find out what are the genes related. So what is Linux? You people heard about Linux, right? So what it is? Yeah, Linux is an operating system. So what is an operating system? Like once you go and you buy a new laptop, they will ask you, okay, you need operating system to install before, or you can do it yourself. So mostly, like people are going for Windows because it is very user friendly and you know like, how to use it. Because first it came Windows, later it is Unix came. So basically, it is a Unix, and it is open source. Means you can download the code. If you know the programming or how to write it, you can change accordingly. Okay, you can add your own programs in the operating system, and other people can use it. So Linux is an open source, I told you. So it is not that much flexible compared to Windows, but it is more powerful. So due to that, a lot of people are using, like in the companies, like they are doing very good processing, and they can enable more security. Like the antivirus, and there is no need for Linux mostly. Okay, but in the Windows you need. So Linux means they can change the security level so that someone cannot go and access like the case of virus. So you can increase your security level and out. So because it is an open source, you know the code. Okay. So there are a lot of flavors of Linux. Like one is Fedora, Red Hat Enterprises. So they are giving Fedora is freely available. For the Red Hat Enterprise, I think we need to pay a little bit money. Not that much. It may be 1,000 or 2,000 rupees. There are Ubuntu, I think I installed in the systems, and there are CentOS and the flavor. So there are a lot of things. So basically the commands are same. So if you know the Unix commands, it will work in all the these Linux-based operating systems. I think even Macintosh, like the Apple, it is also from the Unix. So they change the operating system. So Linux is the open source and secure. So a lot of scientific programs written specifically for a Unix, and no need to install all the programs. Like if you install the Linux, Python will be there available, Perl will be there, Java will be there. Like you can have the option to install while you are installing the operating system. But in the case of Windows, if you install Windows, nothing came from that. You have to, if you want to install another Java, you need to download Java, you have to install it, right? But in here, everything will come along with the Unix, okay? So in the case of analysis pipelines, you can easily build your own analysis pipelines using the Linux, okay? So in the bioinformatics, mostly everyone is using Linux-based systems, okay? I think everyone log into Ubuntu. So you can see here, there is called a terminal. If you just click it, or you can right click there, you can see opening terminal, okay? So it is something like we can, like in the Windows there is a command called cmd, like if you just give cmd. I think it's not coming, some problems. The command to cmd in the Windows, and then you can give some commands, okay. But we are rarely using it. But here, if you want to interact with the Linux, using the terminal is very powerful. So if you want to connect to other server, you can just give the command. So it will go and connect to server, and you can work from here. So this is called a terminal. So I'll tell you some basic commands. So first one is the ls command. Okay, you can type there. You can just give ls. It will list what are the files and the folders there. Okay, so you are in a directory. So you need to see what are the files and folders in the particular directory. So if you give ls command, it will show okay what is there. Okay. So if you want to see the contents of the files in the list with the modification date, etc., you have to give ls minus ltr. Okay. You can try it. You can try all the commands I am writing here. So it means ls, then you are passing some parameters. Minus l means to list. T is to give the modification time. R is in the reverse way. Okay. If you give it, you will get the last file shows which is created on the last time. Okay. So I will tell you next one. How to make a directory. You try all this and files in a particular form. Okay. Next, how we can create a directory. Okay. So there is a command called mkdir, make directory. That's a short form of make directory, mkdir. So I am going to create a directory in my name, mkdir. Then space, I give db. Okay. I am just giving ls minus ltr. Now you can see directory being created. So now you know how to create a file, how to remove the file, how to create a folder, and how to remove a folder. Okay. So now you can create a folder use your name. So mkdir I am using db. So I just want to go inside the folder. Okay. So I'm just listing. So to go inside a folder, you can use the command cd, change directory. Okay. Then just give the name. So if you are typing your name completely, without that, you can just give the first letter, then press the tab, it will automatically fill it. Okay. Suppose my name, I just give B. Then I press tab, so it will fill it. So it is very easy. Because your folder name is very big, no need to type the entire thing. So if you give the first two letters, which is unique, then press a tab, it will try to fill it. Okay. So I am inside the folder bb. If you want to know the working directory, you can use the command pwd. The name is print working directory. Okay, so it will show the complete path, /home, .extend, desktop db. So if you have some files in the C drive or D drive in your Windows, you know the path, D drive / workspace or something like that. So like that, in Linux you have to give the complete name, you have to give the command pwd. So it will show the current path, the complete path. Okay. So now db. So if I want to go outside db, you have to give cd change directory .. means it will go just behind. Okay. Now I am giving pwd. Now we are in /home extend desktop. Next is move command. Maybe you can remove or you can move a folder from one place to another. So the command is mv. Okay. So I am going to rename Bibin folder to test. So I am giving mv Bibin to test. Okay. So you can see now it is test. You can see what are the processes running in the server. Okay. So you can see the top one is top, there is nothing running. Okay. So these are the programs which is prepared for running the operating systems. If you want more expression, you can just press C to show what are the commands, the complete commands. Okay. So I will show you when we are going to do the RNA-seq analysis. Some of the programs will take 50-20 minutes. So we can see whether the program is completed or not, or how much resource is using. You can use the top command. So it will show the program is running and the resource is used. Okay. So you can press Ctrl C to exit from this window. Ctrl C. Okay. So if you want to clear the screen, you can use clear command. CLER, clear command. Just enter to clear. CLER, clear. Ctrl C to exit from the top command. To clear the screen, you can use the command clear. CLER. Also, there is a shortcut. Ctrl L. Maybe you can use next. Okay. And if you want to see the commands you use, the history. Okay, you can just give history. It will show what are the commands you used before. Okay, so you can see that last one is 443 clear. Okay, so if you want to repeat some of the commands you used, you have the number. Like suppose I am giving a big command, something, giving some arguments and that. So it is difficult to read on it by typing again. So if you know the number, just give exclamatory the number, it will do the process. So I am going to clear it again. So I am going to give, so clear is the 443 command. Okay. So I am giving exclamatory 443. Okay. So I am telling them the next to execute the 443 command, which is a clear. So it did again clear the screen. Okay. Maybe your number will be different. Clear. So because in the history your clear command is in the 443. So here another example I show you. I am removing the file test.txt. So test.txt. Okay. Again I am going to history. So now I don't have any text files here. Okay. I remove it. So I want to create it again. So I am going to use the history. So here 438 is touch abc.txt. So I am again running exclamatory 438. Okay. So you can see now it created the, because it executes the same command and it created again the abc.txt. Okay, I am giving you one work to do. Can you go to NCBI to download any mRNA file? You know how to do it? Okay. Can you do it? Can you please go to NCBI? Whatever. In Linux you can, if you have a Mozilla, Firefox. So go to NCBI. So I am going to, I want to download the protein sequence or DNA sequence of the gene ID 1. I think 1 is A or B of human. Okay. So here, where you will go, drop down, you have to go to gene. Right? Then give the gene ID. Enter. So it will show all the details of the A1B gene. Okay. So gene ID 1 is the gene ID of the A1B gene of human. Okay. So that is a unique ID. If you know the gene ID, it is a unique. It won't change. So you can see here it is a summary of the complete genes. So that coefficient name alpha 1B glycoprotein gene. And if you go down, so here you can see the position of the genome, like chromosome positions and expression details, all publication details. Go down, you can see the number of mRNAs. So here you can see only one mRNA. Okay. You know alternate splicing mechanism. So what is the alternate splicing gene? Yeah. So what is the specialty of a alternate splicing gene? Like how you can identify a gene. So I am giving you details of a gene. How you can tell it is alternate splicing? If a gene is having only one protein, it is not alternate splicing. If it is having many protein, it is alternate splicing. Because during the splicing, you get
Alternative splicing.
yeah, alternative splicing. Yeah. So if a gene is having multiple proteins, that means it is an alternate splicing gene. If it is having a single protein, it's not an alternate splicing gene. So here you can see it is having only one mRNA and only one protein. It is not an alternate splicing gene. Okay. So I am opening another tab. I am looking for another gene. Gene ID 2257. So it is a FTF toll gene, and you can, if you go down, you can see how many mRNAs? 5 mRNAs. Okay. So this gene is having 5 mRNAs. So it is an alternate splicing gene. So each. Sorry? No, I know the genes. That's what I told. 2257. If you go to 2, number gene ID 2, I think it is having 2 mRNAs. You can see here, not summary, mRNA summary, right? Scroll down, you can see mRNAs and proteins. If you go down, scroll down towards the end of the page, you can see the mRNAs and proteins. Here you can see 5 mRNAs. Okay. In the case of A1B, there is only one mRNA. Means it is not alternate splicing gene. And you know the NMID and NPID. NMID is for mRNA ID, and then NPID is for the protein. And there will be versions like 0.1, 0.2. Like now, the build may be the first will be 0.1 version. So maybe the next build they may change some of the details. So in that case, they will change the version ID. So the NMID, the first part will be always same, but the version may change. Okay, now depends on the build. So here you can see the NPID, that is a 0.2 version. Okay, so maybe it is updated one time. So here you can see for the FGF toll gene, 5 mRNAs and 5 proteins. And if you click the NMID, open a new tab, you will get the details of the mRNA. Now you got the details of the gene. Okay, the previous page. Here you get the mRNA. So usually it will show the GenBank format, GBK format. So the GBK format, there will be 3 parts. First one is the summary or the metadata. Okay, about all the genes and all. Then the feature details. At the end, there will be a sequencing part. Okay. So here, the top you can see the length of the mRNA. How many base pairs. And here, if you are going down, you will have the CDS information. And if you click the CDS here, it will show the CDS sequence from the FASTA file. Okay. And if you open the NP, the protein file, again it is in the GenBank format and it will show the protein sequence. So here it is a 495 amino acid. So you can see the protein sequence and the CDS, so it will show the exon, what are the coordinates of the exon and the protein sequence. Okay. Can you please download the sequence? If you go top, send to file. We have a lot of formats, so usually we will say the sequence in FASTA format. Okay, so FASTA, then create a file, and you can do save it. Path will be /home/gen, there downloads, if you give tab, it will show sequence.pasta. Okay, that is download one. Okay, to where? To the current directory. Okay, or I am going to put it in the Bibin. Maybe I can give Bibin. Okay, just enter. So it will copy the file. It will move the file from download folder to the Bibin folder. So I am going inside Bibin, CD Bibin. Then I am getting ls-ltr. You can see the sequence of pasta is there. Okay. Okay. So the file I download, which we download, it is in the downloads folder. So the complete path of the downloads folder is /home omixgen downloads. Okay. Okay. So if you want to read how many lines are present in the file, you can use wc -n. Okay. Wait for -n then the file name. So I am going to check how many lines are there in the sequence for pasta. So I am giving 1 minute. WC -L then sequence for pasta. So it is showing it is only 10 lines. Did you count the lines? If you want to see the file without opening it, you can use the command more. Okay. I need more sequence.pasta. Now you can count how many lines are there. Last one is 1 space is there. So it will counted that also. Okay. Okay. More is the command. It will just read the file. If it is a big file, it will read the file and it will show the beginning of the file. Okay, like in the console. So like more, there is another command called less. It also the same thing. Okay, so I just open the file. Not opening file, but just to view the contents without opening it. Okay. So I can exit from here like giving Q. Okay. Okay, just try less sequence of pasta then Q. Okay. So if I have a file, you need to find out the how many sequences are there. Okay, so every sequence will start with the greater than symbol, right, in the pasta. So if you have a file with 100 sequences, so you should have 100 headers, right? So without opening it, you need to find out how many sequences are there in the file. So you can use a command called grep. So grep, you can give the character to be searched. So in this case, greater than symbol. Okay. Then I can give the file. Q2 is Q. Just Q. Fetch the headers from the pasta file. Okay. So I am using a command called grep. Then I have to give the character where to be searched. So I am searching for the symbol greater than symbol because pasta files the headers should be starting with the greater than symbol. Then the file name. Okay. Double quotes are to give the now in the sequence of pasta and saving those data into header.txt. Okay. So I am going to give again more header.txt. You can see only the pasta header is there. Okay. So you are processing the file. Like suppose you download the complete human genome. So there are a number of sequences there. So you just want to see how many sequences are there, or just to give the header sequence, you can use the command. So it will read the pasta file and extract the headers and save it to another file like headers.txt.
So we go to the code for WC head date. Okay. So head date. So if you want to see the top of their file, you can use the command head. So
and speak sequence of pasta. So now actually it is already high 10 lines, so it will show complete one. Suppose it is a big file, it will show only the top one. Okay. Okay. So I'll give another example. If you pass the number of files you want to see from the top, you can give head minus, suppose first 2 lines. I can give 2. Let's sequence for pasta. You will show only first 2 lines. So like here, there is a command called tail. So it will show the lines on the top. Okay, so if I give tail minus 2 sequence for pasta, it will show the last 2 lines. Actually, there is a slash n, so that is what it's showing. DAES, then after that, line also. You know how it means. If you are running a command, it will take some hours to complete. So you cannot wait to complete completion because maybe it will take 1 hour. So you don't want to sit ideally for 1 hour. So what will do? And you want to see what is status of the file because while processing it will show some status. Okay, this complete, this step is complete like that. So if you give a no-hub command, then the command will be executed and give the ampersand sequence. It will run in the background of the server, and if there is any arguments and status is passing, it will create a file called knock.out. And if you just view the knock.out, you can see the status of the file. You understand it? We are running a big program. Suppose you are trying to processing human genome from all the chromosomes, 24. Then after completion of the chromosome 1, it will show okay, chromosome 1 is closed. Okay. So for chromosome 1, it took around 20 minutes. So maybe you have to wait for hours to come in. Okay. So what you have to go outside, you have to do some other activities. What will you do? You can give no hub. Okay. Then space the command you want to execute. Then space ampersand. Then enter. So what it will do? It will execute the command in the server in the background. Okay. And if there is any arguments it is passing in between, like okay, this chromosome is closed, it will create another file like nohub.out and it will capture this. So if you come after 2 hours, you can just go and check in the nohub.out, you can see how many chromosomes are closed. Okay. So now we don't have that much detail process to show. Maybe I can show you LS. If you give LS, it will show that it's the files and folders. And I am giving knock.out, then ampersand. So it will create a file called knock.out and it will carry all the result of the LS command. Okay. So you can try. Suppose LS, so I have already 2 comments. So I am giving no space LS space ampersand. No HUP, no hub, that is a full form. No hub space LS, that is list. Maybe I can give LS minus LTR. LS minus LTR. Then space ampersand. Okay. Just give enter, it will show. No hub, no input value. Okay, it is completed. If you give again LS minus LTR, you can see there is a file called knock.out. Okay. If you want to view it, you can give more knock.out. You can see the comment. So the LS comment. You know PWD you already know what is the code. Clear also you know. Clear the screen. Okay. So first the escape. Okay. You can give plus I so that you can insert the some of the characters, whatever things you can type. You can type the file. Okay, if you print plus I, it will go to edit mode. You can be able to enter some of the data in the open file. Now, wherever you want to enter something, you can give escape. Yeah, because actually it is having some. Start. So we are talking about the text editor in Linux, and we just started the text editor Vim. Okay, so you opened a file and you try to type something using the insert mode I. So as I told, there are 2 modes. One is the insert mode and one is the command mode. So insert mode is we can edit some, we can insert some data in the text file. So that is insert mode. So now you type something. You want to quit the file. So now you open the file. Okay, you need to close it. You can give escape. So escape will, when you press, it will go to the command mode. Okay. Then colon Q. Okay, first one, colon Q. Just to quit it. So I'll show you. Escape, colon Q. Okay, because we edit something, that's what. So escape, colon Q, you have to give exclamatory mark. Okay, then press enter. Okay, escape, colon Q. Okay, you have to give exclamatory mark. So exclamatory colon Q. Now you can try. Again open it. Just open it, don't edit it. And just give colon Q. No need to put exclamation because we will be editing it. To open it again, I am going to enter something and I need to write and I need to put it. Okay? So I am going to last line. I am going to enter. Test. Okay. Last line I given test. Now I am going to save and quit. So again, escape. So for saving and quitting, I just press escape. So go to command 1, then colon, right, W, then quit Q, enter. Okay. Exclamatory, sorry, escape to go to the command mode, then colon, give W is for writing, then Q, then enter. So it will write the modification what you have done and it will close the file. Okay. So I just enter something testing at the end of my file. Now again going to open it and see whether it is there or not. And again give BA. Look, test is there because it is already saved. Okay. Why? So if you want to copy some lines, okay, but you just give YY, escape YY, go to the line, just give escape YY, and if you want to paste it, go to the place where you want to paste it, then you press P. I will show you the example. I want to copy the header, okay, so I just giving YY, escape YY, and I want to print at the end of the line. I just give P. It will paste the line. You can try it. Go to the first line, open the file, go to the first line, escape YY. It will yam it. One line it will yam. And escape again, go to the last line, first P. So I want to copy 3 lines. I can give escape 3 YY. So 3 lines should be copied in memory and go to the place where you want to paste it. So you need to paste 5 times. You can give escape 5 YY. Sorry. Escape. So I'll try it again. Escape 3 YY. Go to the place where you want to paste it. Then escape 5 P. Okay. So 5 times it printed. What the things we copied it printed 5 times. So it is like a cut copy paste like that. What you are doing in the Windows. It will be very fast. Okay. So WQ, WYY. So NP, I am just giving N. If you can give any number, that means number of times it will print. Next, how to delete some lines. You can use the command DD, escape DD. It will remove the line. If you want to remove 2 lines, escape 2 DD, 2 lines will be removed. Okay? You can try it. Look, I am going to remove last 3 lines, escape 3 DD. It will redo. Okay, just give escape dot, it will do the previous command what you executed. That is for repetition. So here I am going, I am just giving dot to remove first 3, then again next 3. Okay? How to paste it, how to delete one line, multiple lines, how to repeat the same command. Okay? So next, how to remove a single character. Just give escape X. Okay. So you type something, you want to delete it. So escape you go to the command mode, give command X is to remove a character. Okay. Next, how to move the cursor to the end line. So I want to go to the fifth line. Just give escape colon 5. Okay, I can see the cursor is going to fifth line. So if you open a file, big file, you want to go to some 100 line, escape colon 100. You go to the 100 line. You can try it. Some file manipulations using this BA editor. So one is sort command. So I just going to open another file. So I just close this file. So BA test.txt. Okay. And just give some entering some numbers. So 1, 4, 5. 2, 8, 9. Okay. So these are the numbers in this file. I just want to sort this file. Escape, colon, sort. Enter. It will sort the content. Okay, try it. Changes. Okay. Escape U, it will undo the changes. Okay, I am entering some more numbers. 11, 12, 13. Now I give sort. Look. It is sorting like 1, 11, 12, 13, 15. Okay. So it is not a numeric sort. So you have to do a numeric sort in order to get in the right order. Okay. So I again give undo. So if you want to go to for numeric sort, you have to give end sort. So sort end. So escape colon SORT space head. Okay, that's the numeric sort. Now you can see it is coming the same. These are duplicate values. Suppose you have a in your one of your project, you got some gene symbols or gene IDs from different people, and you find there are some duplicates. So you want to remove the duplicates genes from that gene IDs from the list. Suppose I am just giving like 1, again 1, 11, 12, 15. Okay, there are duplicates. So I want to remove the duplicates and I need to sort the file. So you can use sort. If you give U, it will remove the duplicates. And if you want to sort in the numeric way, order N. So sort N. Look, it will remove the duplicates. Sort. It will remove the comments. I will show you. I am going to remove 11 to 15. That is from 11. After 9, everything I need to delete. So escape D capital G. So it will remove 9 and the same line where you are putting your cursor, and after that everything will be deleted. If you want to undo, you can just give U. Escape. Just give U to undo the changes. Particular line and it will be the edit mode. Okay, just try it. You need to just go and make it fast. Okay, try CC. It will remove the line and it will be the edit mode. And the escape I already told, go to the command mode. Here's the escape. If you want to insert a line below the current line, you can just press Smart O, escape O. It will insert a blank line. Okay. And if you want to insert a blank line above the line, current line, you can give capital O. And U I already told to undo the edit, recent edit. And the capital to all the edits in the single line, to undo all the edits. Capital. If you give capital Z, it will right and give it a shortcut. Okay. I just give it here. Shift Z. It will save and it will quit it. Capital Z. If you colon I already told you, hit PA and discard any changes you have made since last time. And capital D to delete characters from cursor to the end of the line. You can just try it, okay? Okay, here this is important, CW to replace a word. Okay, so I just give you an example. So I want to change some of the words. So I have to give CW and you can edit it. Okay. So I edited here to now. So go to the where you want to edit it, escape, then CW. Okay. So you can replace it. Now you can type what you want to replace. Okay. So I replaced it here to now. So there are some other shortcuts. If you give capital H, it will go to the top line of the screen. Okay. If your cursor is in the middle of the file, just give capital H, it will go to the top of the screen. And if you give just capital M, it will go to the middle line of the screen. Like if you have 10 lines, and if you give capital M, it will go to the 5th line. And if you give capital L, it will go to the last line of the screen. Actually, you can remember it is go to the screen, not the file. Okay. The screen what you are seeing, go to the top, bottom or middle, it will go. It will go to the file. Okay, next is how to search inside a file. So I made a standard FASTA file. So you have 4 genes and sequences. You want to search for the each genes. Okay. Try going to search how many genes are there or the gene word. So you have to give escape, backslash, gene. Okay. You can see, go to the second line. Okay, because I searched at the beginning. If you want to repeat the search, you can press N. You go to the third one, again N, you go to the fourth one. Okay, so I press N. Can try make a standard FASTA file to print genes with just insert it. Okay, search to the keyword G from top to bottom. I am pressing N, you will go to the next search. Okay, N. So if I am at the bottom, I want to go from bottom to top search. Giving question mark G, enter. So you will go to the from down to up. Again repeat the search like this. Okay, I think maybe now you got some idea about the Unix commands, creating some files and all. I'll give you some more things like which is needed. I will put in the slides. Usually if you download some files like some software or something like that, it will be coming in the zip format. It's not .zip, it's coming like .tar.gz or .gz. So it is a gzip format. Okay, really nice. So how to make a tar.gz file, how to extract the contents, like I can teach about this. Okay, so I have sequence.FASTA. I am making a copy of the sequence of FASTA. So cp sequence.FASTA to sequence1.FASTA. So it will make a copy of the sequence to sequence 1. Okay. So you can give adjustments here. You can see sequence 1 FASTA and sequence.FASTA. I again making one more copy, sequence 2 FASTA. Okay. So you have 3 FASTA files. Sequence of FASTA, sequence 1.FASTA, sequence 2.FASTA. I want to send these FASTA files to one customer. Okay, so I need to make a, so what we'll do, we'll copy the faster files into a directory. Then it will be, suppose the size is very huge, you need to compress it. Okay, so you need to go to the WinRAR or whatever thing, WinZip, you will zip it. Sorry, yes, you will zip the file, you will send it. Okay, so in Linux, there are commands to use it. So first I will make a tar file. Tar file will combine all the files what you needed. So you are using star minus create virtual verbose mode like that. CVF. Okay. So then I will give the name of the file I want to create. So I am making like fasta.tar. Okay. So tar minus CVF, the file name you want to create, .tar space, then which files? I give sequence.fa fasta, sequence1.fasta, sequence2.fasta. So what it will do? It will read sequence 1, 2, 3 fasta. It will make a folder like a fasta.tar. It will put all the files into one file. I am executing it. Okay. Give ls area. You can see fasta.tar is there. Okay. So it contains 3 sequences: sequence.fasta, sequence1.fasta, sequence2.fasta. Now I need to compress, because if you want to see the size of the file, you can use DU, disk usage, minus SH to read in the human way. Okay. Fasta.tar. You will 12 KB. That's size. 12 KB. If it is GB, 12G like that you show. Okay, 12 KB is the file size. Next, I need to gzip it. Gzip. So there is a command gzip fasta.tar. Now you can see it will create the file fasta.tar.gzip. Okay, so you make the combine the files to one folder, make it tar file, then again you zip it. Now you can see the size of the file. Du minus sh fasta.tar.gzip. It is 4 KB. Before it was 12 KB, now it is 4 KB. But if it is like a 1 GB, if you zip it, maybe you will get 200 MB or something, maybe less than that, according to the content. Okay. So now I want to see, okay, whether the files are there or not. So I want to check it and making a folder here, test. Okay. And I am moving the, or I am copying the file cp fasta.tar user to test. Okay. I am copying the created tar.gzip file to the folder test. I am going to the folder test. Okay, in the test, now I have the created file. This is a zipped file. So now I am going to unzip it to see the contents. So the command is tar minus xvf. Okay, to gzip, so that's what you unzip is xvf. Same thing. We have to create, it is like tar minus cvf. Okay, so C for creation. So extraction is xvf. And if it is a gzip file, I will give is an xvf. So I am under that for file name. So it will extend the file. I can see. So it created 3 files, extra 3 files. I want to check the contents. Yes, sequence row faster. You can see the contents. Got it? So now you zip the files. You can zip any number of files. Okay. So no need to, it is difficult to give sequence.fasta, sequence 1, sequence 2. Maybe you can use tar.fasta. So it will go search for every file which I.fasta extension. It will make the file. Maybe we can try. Same thing, I am removing the file. I remove everything. I am removing the created fasta.tar.gzip. Again I am doing it. Okay, I have the free fasta file. I am creating a file tar minus cvf. Okay, fasta.tar space star.fasta. Okay. Now I am going to gzip fasta.tar zip it. So now this tar.gzip file I am moving it. So I am copying it fasta.tar to test. In test I am going to check. Is there? Is there? I am going to under insert xvf files are extracted. It is simple because if you know the programming, it will be fast. No need to give all the names type. With a single command, you can zip everything and make a file. Where you are going this one? So I am going to download a GF file. Maybe you know about GF file, GTF file. Like if you want to download a human genome, okay, and you need to download the contents like the gene information. So you can download the FASTA file separately. You can download the gene model file, means the information about the what is the sequence. Okay, the FASTA file contains only the character, the chromosome number, and the only the sequence. If you want to have any other information, if you download it, you don't get anything. You can only the ATKs. But if you want to extract some sequence or a gene from the FASTA file, you need the coordinate. Okay, so for a gene, from where to where I need to extract. So those information is represented as DAY-4 information. So I will show you that tomorrow I am going to go here, this exercise. So I am going to download the GF. It won't be much big, this maybe some 30-40 MB. So search for genome and give human. Okay, K. So Homo sapiens. So you can see here. First one is the download of sequence in FASTA format, genome, transcript, protein. Okay, so it is a FASTA file. It is a big size. So here you can see the download genome annotation files. The format GFF, GenBank or tabular format. Okay, usually in our NGS analysis we will go for GFF file or GTF file. GTF also there. So here if you click it and right click it, you can get the link. Copy link location. I copy the address. Okay. Now I am going to download the folder. So I go to the terminal. I am going to download here. So there is a command to download a file from the site. If you have a site. Means wget. Okay. W is the command. -c. I suppose in between there is some interruption happens and it net gone and after some day it came back. So in that case it should resume from where it stopped. So that's what I give -c. If you give -c, if it is again downloading, it will start from where it stopped. Okay. Then I can give the path of the file. So this is the path I copy from the NCD. Okay. Yeah, if you go here, the GFF. That's a format. Right click it, copy the link location. If you simply click it, it will download from the browser. Okay, from the browser, but it will download. But if I am working in a server or somewhere, I need the same path, so I have to download using a command. Otherwise, I need to download into the downloads and then again to move it. Okay. Okay, so I'll show you. Running now, it is going to connect the NCBA. Started downloading. You can see the progress 1%. Now I'm going to stop it. I stop it into 20%. wget get webget, I think that's wget -c to resume, like it to continue if you stop it. So I stopped it between 20%. Okay, suppose next board it stopped in between. I am going to rest again. I am giving this command. So it will check where it's stopped. You can see +++ symbol. Now it again continues from there, resume from where it's stopped. Okay, you can see the progress. So you can just check the size of the file. So I think maybe show. It is a 48 MB short, right? While downloading must be short, then and writing 48 MB. Okay, so that's 48 MB size of the file. So I'm just giving elements here. So I have GCF underscore, that is a file name. So I am going to unzip it. So it is a G-zip the file. So for unzipping it, can use the G-unzip. Some people tell unzip, but it is a G-unzip. Okay, so unzip the G-zip file. G-unzip, then the file name. Enter. Now it is extracting the file. C.gf file, and I am checking the size du minus sh. So it is 1.2 GB. So after extracting the 14 MB, it is 1.2 GB. So you can see how much it is. So according to the algorithm, it is very good algorithm they use to fit the file. The file, I cannot open it. It's a big file. I am using less. Okay, this is the starting of the file. So it will show the GFF version, then the information about which build and you can see this is a tab delimited file. Like except this lines starting with the hash, remaining if you copy and paste in Excel, it will come in each column. So that is the tab delimited file. Okay. So first one is the coordinate ID. That is the coordinate ID. Then the website it is, and then region, like it is a DNA or whatever it is. Then the starter at the edge of the particular region, and a plus is strand. Then here the other information like taxonomy ID, chromosome, molecular type, genomic DNA, like all the information. So here is a pseudo gene. Actually, from here to here is a pseudo gene. Okay. So you can see the transcript of that particular gene, and here you can see that mRNA. Okay. You want to see it, right? If you want to go down, you can just give space to read next time. So next screen. Go. So here you can see, like first it will show like what is the coding. Okay, in C what is the coding, and the region what the first file contains. And here you can see like here, suppose here, this is a gene. Okay, gene ID is 79501. Okay, and the gene name is OR4F5. And description is factory, subfamily for subfamily F member. Okay, so you will get the gene information. And here this is the coordinate 65419 71585. So chromosome 1 65419 71585 is this particular gene. And down you can see the mRNA. So this is the position of the mRNA. Same, the complete is mRNA. And this is the first exon. Okay, and this is the second exon, and so on. Okay, so it will give like the complete position, the only position, that the gene, genomic coordinate, the particular gene's mRNA, the particular coordinates exon, then CDS. I think there is no protein. The CDS will give the protein, I think. Maybe I can use. Yeah, here CDS. Yeah, CDS like that. And this is the next gene. Okay. This is the remaining of the previous one. 2 CDS are there. So this is the corresponding NPIDs. Okay. I think here the CDS means like the first exon the CDS, the second exon the CDS. We need to coordinate to make the complete CDS. Because you can see the NPID is same. Okay. Okay, anyway, I did this exercise to understand you like where you are using this GZIP and the unzip. Okay, because you are dealing with the bioinformatics, if you download some files, it will be in this format. Okay, so here is a single file, that's what is zip. If there are multiple files, it will be then tar or GZIP form, because there is tar everything, and then it will zip. So in that case, you have to use tar minus select B instead of file. Okay, so I think maybe now you got some exposure to Unix systems, some commands, and some basic bioinformatics, how to download a sequence, how to extract it, how to view the sequence, how to go search something in the files, like that, right? So now I'm going for some basic of the Perl. To learn some basics of Perl. So it is known as some bioinformatics language basically. But nowadays people are using some other scripting language like Python, and some nowadays people are using R for statistic purpose and all. But it will be good like as a bioinformatics person, you should not list one programming language, which is a scripting language. So there are two types of language. One is scripting language and one is object-oriented. So Java and C++, these are the object-oriented languages. And the scripting languages is like it is used to manipulate text files. It is very fast to manipulate text files. So but the full form is practical extraction and report language. So in 1987, Lowry Ward invented this language. And actually, it is not a procedural language, it is both procedural and object-oriented. So I am not going in detail about those things because that's a complete IT things, computer science. So it is called an interpreted language. Interpreted language is like, suppose if you write a code, suppose 50 lines of code, and in the interpreted language, it will interpret, like once you run it, it will read the first line, and if it is perfect, it will go and read the second line. Okay, and it will go, that is, it is read one by one. But in the case of the object-oriented language, it will read what in the bioinformatics. So writing some code to extract, suppose you want to translate the mRNA sequence. Okay, so actually there are a lot of people that did it earlier. So what they will do, they will make a Perl module, they will put in some third-party sites. One is like CPAN. The performance Perl arcade network, comprehensive Perl arcade network. So before doing your thing, you have to go there, the site, search for the particular module. Suppose you can go there, they can type, translate. Okay, if there is any module is available, you can just install in your system, just call the command. No need to write a code. So it will be making your life easy. So no need to write everything, because mostly that particular code is available in the third-party site. So go there, search, download it, install it, call in your code. So you can make the code simplified and you can trust it, because before, after checking everything, only they will upload the file. Okay. Okay. Now we can type. I think in all your system, Perl is there. So to see whether the particular module, that program is there, you can use the command where is. Just type where is space Perl, enter. Okay. So it is showing the path where you there find the Perl. So you can see this is one path, user bin Perl, and here also you can see this Perl. Or another command is which Perl. You can use which Perl. Which Perl. So it will show the exact path where the Perl is installed. Okay, this is not only for Perl, like suppose, okay, for tomorrow program, maybe there will be some other tools I am using. Maybe I think maybe you heard about SAM tools. There is a tool called SAM tools. So I am trying to find the location. So where is SAM tools? So it will show you the path or which SAM tools. Okay. So if any program is installed in Linux, if you want to see the location where it's installed, you can use the commands where is or which. You are ready? You are ready, right? Okay, now we are going to write your first year Perl code. We can open a V8 some test.pl. Okay, okay, I am going to write it. Okay, so we can see the first line, hash, then exclamation. I think you open a file, test.pl. So first line I used hash, exclamatory, then I given slash user bin Perl, then it's space minus w. Okay. Okay. Then I just give print other word. Okay. Then slash. I'll explain what I'm going to do. So you know slash user bin Perl. So that is the part of the Perl compiler. Like you before you use which Perl or where is Perl, you saw this part. So first hash exclamatory is called a shebang constant. So what it means is that it will tell the Perl like this is the place where the compiler is installed. Okay. So hash exclamatory, then the path of the Perl compiler minus w is called a switch. I think switch. So like it will change the compilation of the compiler. So minus w is to enable warnings. Okay, if there is any problems, it will show the warnings. Maybe you can easily understand what is the problem in your code. Okay, if you miss something or if you duplicate some of the variables, it will show some errors and warnings. So if you enable this switch, the minus W, it will be that you can easily understand what is issues. Okay. Then next line I given print. Print is a command in the Perl to print something in the console. Okay. Then double quotes I given a phrase like a hello world. Okay. Then I given slash n. Slash n is to like enter. Just giving enter. Like I am telling Perl to print hello world in the console and enter. Okay. So now I am going to execute this program. So escape, colon, right and quit. So to compile it, you have to give Perl space the program name. Okay. So Perl test.pl, give enter. So it will show print hello world. So there is a function called length in the Perl. If you provide a sequence or a string to the particular function, it will return the number of characters. That is the length of the sequence which we provided. Okay. So the result will be an integer, right? So ATGC number is, there are 4 numbers. So the result will be 4. So I am storing to another variable like $L. Okay. So once you execute, it will fetch the $C and it knows the value of the $C is ATGC, and in the next line it will calculate the length of the ATGC, it will return and it will store to the variable $L. Then I am going to print the result. So I am giving print in brackets, I am giving the length of $C is $L/n. So while running, the Perl program will fetch the values of $C and $L and it will print the length of ATGC is 4. Okay?
Good afternoon everyone. So hereby we have came to an end of our today's session. The rest of the session will be continued tomorrow by the same resource person, Dr. Bibin Balan, and tomorrow he will be handling 2 sessions. The morning session will start from 9:30 a.m. to 2:30 p.m. and on the topic Next Generation Sequence, 5 formats, Introduction to RNA, Sequence Analysis, and the afternoon session starts from 1:30 p.m. to 3:30 p.m. on the topic RNA, Sequence Data Analysis, Pre-processing, Mapping Reference Genome, DEG Identification. So once again I would like to extend my gratitude to Dr. Bibin Balan for patiently interacting with us, and of course our dear participants who were attending throughout. Thank you very much.